Salut à tous. Hello, hello everyone. That means in French. We are going to continue our foundation engineering class. We are on chapter number 4, I think. Special cases of ultimate bearing capacity of shallow foundation. And today we will do this section number 4 of this chapter, which is about strong soil layer underlain by weak soil. C5 soil. Okay, it means the soil have both cohesion and friction. Okay, so please remember that this case is when the bottom layer is the weaker soil layer. Okay, we have two soil layers. The upper one is stronger than the bottom one. Okay, the inverse case will be the next point 5. Okay, so let's go. So, and also remember, both soil layer have the cohesion and friction angle, okay, except the exceptional cases. So we are going to see in this kind of situation what will happen to the bearing capacity, to the ultimate bearing capacity, how the bottom layer will influence the bearing capacity, because the bottom layer is softer, is weaker than the upper one, so obviously it will decrease the bearing capacity. Okay, so again, the general equation of bearing capacity, this one we did in the chapter number 3, is once again for only when the soil is uniform, homogeneous soil, and that uniformity, that soil extend to significant depths. Okay, with constant cohesion, constant frictional angle, and constant unit weight. It only in that case that this equation, this formula can be applied. Okay. However, you know very well that actual construction site in the real world, it doesn't work like that. Soil profile are always actually maybe not always, but very often layered, and it makes the analysis more complex. So we want to know in such cases what will happen if the failure surface, when the ultimate state is reached, the failure surface may pass through multiple soil layers. So by now you should know that everything is about the failure line, the failure surface. If that failure line is confined in one soil layer, then only that soil layer will affect the bearing capacity. But if the failure line, the failure surface is crossing different soil layer, it means all these soil will contribute, affect the bearing capacity. Okay, so in this section we will then talk about the method proposed by Mayrov and also Mayrov and Hannah to estimate the ultimate bearing capacity in this kind of situation. Okay, so this figure is showing an illustration of what I was talking about. We have here two soil layers. The upper soil layer, which is the stronger one, and another soil layer here bottom. This line is the limit between the both. So the stronger one is here, and this one is the weaker soil layer, and both have cohesion and friction angle. Okay, and you can see very well this limit here is crossed by the failure line, you can see what is happening. We will explain all this later, but you can see that this is the footing, and when you are loading on the footing here, pushing, what will happen is that we will have this kind of failure. The strong layer will kind of like punch the softer layer. Okay, it is kind of a translation of this footing, and this punch will behave like a footing acting on the softer soil layer, and we'll have this general shear failure. Okay, and I think you know what is general shear failure now. In the chapter 3 we did it. So in this kind of situation, the bottom soil layer, the bottom weak layer, will definitely influence the ultimate bearing capacity of your foundation. But in this case, we can see clearly that the failure surface, okay, is not crossing the border. This is the border between the strong layer and the bottom weak layer. So in this case, we can say safely that the bottom layer has no influence. But for this situation to happen, this h, the depth, means the distance between the bottom of the footing to the boundary. The h need to be really large, otherwise we will not have this situation. Okay, so this is what we are going to discuss today and see what is the ultimate bearing capacity in these cases. Okay, let's continue. So let's keep this here, okay, since we are going to use it, the two figures. So this figure is showing, this is strip footing, okay, continuous foundation resting on strong layer. The upper one is stronger and bottom layer is weaker. Okay, so physical property of both soil layer are provided. The physical property, it means unit weight, cohesion, frictional angle. Okay, we have this here, and already explained. Okay, I already explained all this. If h is relatively small, the h is the distance between the bottom of this foundation, the base of the footing, to the limit, the boundary between the two soil layers. Okay, if this h is relatively small compared to the foundation, the dimension b, then punching shear failure will occur in the top of the soil. This punching shear failure. Okay, and this punching failure is followed by a general shear failure. Okay, so the top layer, if you hear alpha, if you hear lambda 1, phi 1, c1, it means for the top layer. 2 is for the bottom layer. Okay, let's agree on this before we continue. So this case is the special case that we are going to investigate now, because the previous one, when the h, this limit is large enough, the foundation will not be affected by the second layer. So we will not investigate this. We will not waste time on this, because it will be just like in chapter 3, the general shear failure we have studied so far. Okay, so we will focus only on this case. Okay, this one. So the ultimate bearing capacity for this kind of problem, we can be use this equation, but let me go directly to this one, this simplified one. This one is the general one.